Hello students, here I want to discuss a topic Chomsky classification of formal languages. This is also known as Chomsky hierarchy of formal languages. Basically in this topic we will discuss the types of grammars and the types of language. So there are four types of grammars: type 0, type 1, type 2 and type 3. The classification of the grammar is on the basis of type of productions they have. So basically the grammar which have all the productions of type 0 is known as type 0 grammar. This is also called unrestricted grammar. The grammar which has all the productions of type 1 is known as type 1 grammar. This is also known as context sensitive grammar. And the grammar which has all the productions of type 2 is known as type 2 grammar and also called context free grammar. And the grammar in which all the productions belong to type 3 is known as type 3 grammar, and this grammar is also called regular grammar. In the type 0 grammar, productions will be of the form alpha to beta, where alpha and beta may be any combination of variable and terminals. And this alpha cannot be null. There is only one thing, that alpha cannot be null. That means you cannot replace epsilon with any combination of variables and terminals. Except this, there is no restriction in the production of this grammar. And if a grammar contains all the productions of this form alpha to beta, where alpha is positive closure of variables and terminals, that means alpha cannot be null, and beta can have any combination of variable and terminals, then this grammar is known as type 0 grammar or unrestricted grammar, since there is no restriction in the production of these grammars. The productions of type 1 grammar are same as the productions of type 0 grammar, except one restriction, that the length of right hand side cannot be less than the length of left hand side. That means in the production alpha to beta, this length of beta will always be greater or equal to the length of this alpha, which is left hand side. So if a grammar contains all the productions of this type alpha to beta, where length of this beta is always greater or equal to the length of alpha, then that grammar is known as type 1 grammar or context sensitive grammar. And why it is called context sensitive grammar? Because the productions of any type 1 grammar can also be written in the form alpha 1a alpha 2 to alpha 1 beta alpha 2, where this alpha 1 and alpha 2 are left and right context respectively. You can see at both sides these left and right context are same. We are just replacing this variable a with beta. It is called replacing a with beta in the context of alpha 1 and alpha 2. So these contexts are same at both the side, at left hand side as well as in the right hand side. And since we have to keep one thing in mind, that the length of right hand side must always be greater or equal to the length of left hand side, it means this beta cannot be null. So we are just replacing this a by beta, so this beta cannot be null. It means alpha 1 and alpha 2 may be any combination of variables and terminals, and beta is also the combination of variables and terminals except null. This is why the type 1 grammar is also called context sensitive grammar. And what is type 2 grammar? So you see, in the productions of this type 1 grammar, if this alpha 1 and alpha 2, that means these left and right contexts are null, then the production is called type 2 production. That means the production of type a to beta, a variable on the left hand side and right hand side may contain any combination of variables and terminals. So there are no context. This is why this type 2 grammar is called context free grammar. So a grammar is having all the productions of type a to alpha where alpha may be any combination of variables and terminals, and this A is from the set of variables. Then that grammar is called type 2 grammar or context free grammar. And what is this type 3 grammar? The type 3 grammar is the grammar which is either right linear or left linear. So the grammar which is either right linear or left linear is called type 3 grammar or regular grammar. Now what is this right linear grammar? So the production of the grammar or the type A to XP or A to X. You can see here this left side contains only one variable. This is same as type 2 production. But here in this type 2 there is no restriction on this right hand side. But we are imposing some restriction on the right hand side also to make it type 3 production. So what is this restriction? This right hand side may now contain only one variable, at most one variable. So this is the case with one variable, this is the case with no variable. So right hand side may contain only one variable, and if this variable is present on the rightmost position, then the grammar is known as right linear grammar. And in the left linear grammar, this variable will be present on the leftmost position. So there will not be any variable, or if it is, there may be at most one variable on the right hand side, and that variable should only be placed in the leftmost position. Then that grammar will be left linear. So if a grammar is either right linear or left linear, then that grammar is called type 3 grammar or regular grammar. Here we should also note a very important point that type 1 production is of type 0 also. The same way the type 2 production is of type 1 also, as well as of type 0 also. And the type 3 production is of type 2 as well as of type 1 and as well as of type 0 also. So if you see the examples of these grammars, every production of type 1 is type 0 also. Every production of type 2 is of type 1 as well as of type 0 also. And every type 3 production belongs to this type 2 and type 1 and type 0 also. So there are these 4 types of grammars. The same way the languages generated by these grammars are of 4 types. Number 1 is recursive enumerable language. A language generated by an unrestricted grammar is called recursive enumerable language. The second language is called context sensitive language. A language L is said to be context sensitive if there exists a context sensitive grammar G such that this L is equal to the language generated by this grammar G, or this L is equal to the language generated by the grammar G union null. And a language is said to be context free if there exists a context free grammar G such that this language L is equal to the language generated by this context free grammar. A language L is said to be regular if there exists a regular grammar, that is a right linear grammar or a left linear grammar, such that this L is equal to language generated by the grammar G. Then this grammar is regular grammar. So there are 4 types of languages also. You see, the language generated by this type 0 grammar is known as type 0 language or recursive enumerable language. The language generated by this type 1 grammar is known as context sensitive language. The language generated by this type 2 grammar is called context free language, and the language generated by this type 3 grammar is known as regular language. And since all the productions which are present in type 3, they are type 2, type 1 and type 0 also. This is why this regular language will also belong to type 2, that is context free, as well as context sensitive, as well as this recursive enumerable language. So all these languages are basically the subsets of another language. A regular language is a subset of context free language, which again is a subset of context sensitive language, and which again is the subset of this recursive enumerable language. And this actually is called Chomsky hierarchy. So you see, in inner box I have written regular language, and in this outer box I have written context free language. It means all regular languages are context free also. The same way all context free languages are context sensitive also. All context sensitive languages are recursive enumerable languages also. It means this regular language is context free as well as context sensitive as well as recursive enumerable. And the automata which we construct to accept the regular languages is finite automata. For context free language, the automata is push down automata. For context sensitive language, this automata is called linear bounded automata. And for recursive enumerable languages, we make Turing machines. So you can say this Turing machine is the most powerful machine which can accept recursive enumerable languages as well as context sensitive languages, context free languages, and regular languages also. And the second most powerful machine is linear bounded automata, which can accept context sensitive languages, context free languages, and regular languages. Then this push down automata comes, which can accept context free languages and regular languages. And the most, you can say, the machine which has very less power is finite automata, which can accept only regular languages. So this hierarchy is known as Chomsky hierarchy. And this classification of all the languages is called Chomsky classification of formal languages. So Chomsky classified all the languages into 4 categories: type 3 language, type 2 language, type 1 language, and type 0 language. They are also called regular language, context free language, context sensitive language, and recursive enumerable language.